Hello, everyone. Welcome and happy Monday. Really glad to have you here for the next session of our Devon and Beyond Security series. If you missed any of the previous sessions, you can find the recordings on the same Devon and Beyond page from where you registered for this session. And while you are there, please take a moment to review the other series and webinars that we have added for you. Our topic today is networking best practices, where you learn obviously about best practices, recommendations, and lessons learned as you plan, deploy, and manage OCI network infrastructures. My name is Renu Bhatt. I'm a program lead with the Customer Enablement team. And today we are lucky to have Ben Woltz and Rafi Shabazian with us as the main presenters. With that, I'll hand it over to Ben. Ben, please take it forward.
Thanks, Renu. Good morning, good afternoon, everybody. We'll start just real quick with some introduction. I know Renu already introduced us, but a little bit more information about us. So my name is Ben Woltz. I'm a principal cloud architect here at Oracle. I'm joined today also presenting with my colleague Rafi Shabazian. And then on the panelists, we have Shailesh and Firasath. All four of us are on the same group and the same team. We are in the shared network and security services group. We help engage with our sales folks and our ECAs and customers directly and help them with anything and everything OCI networking related. So let's cover, this is what we're going to cover today. So these are best practices around network, OCI network and security. We've broken them down into these kind of four subcategories. The first one is network design. So these are going to be things that you might want to think about doing early on in the process, designing the network and how you're going to actually deploy. Then we've got network security best practices, network connectivity best practices, things around FastConnect and IPsec tunnels and those sorts of things. And then we'll round it out with some observability and management, network management best practices. So let's kick it off with some of the network design best practices. So the first one on the list is, might kind of seem very obvious to a lot of people. However, I know Rafi and I can attest to this. When we work with customers, this is one thing that we routinely see customers not doing correctly or not doing at all, and it coming back to bite them. So this is making sure you spend the time early on to do a proper design for your network. Many times we see customers deploying their resources. Maybe it's a database administrator putting a database in. To do that, they need a VCN, they need all the networking constructs. So they run through the wizard and accept all the defaults, and they're up and running, and then they want to connect it or they want to do something else. And that's when we realize there's a problem because they didn't go through and actually think about how to design it the right way. So what we recommend customers do is, in the project plan, make sure you allocate the right resources, folks from your network team, get them involved early, and the time in that project plan for them to go and put this work effort in. That way, going into this that you've got, the right design that meets your requirements. It is actually something that my team we do on a regular basis as well. So if you need help with network design, maybe you got some questions or you want some help with something, you can reach out to your Oracle account team and potentially get myself or Rafi or anybody else on our team to kind of engage and help with that as well. But just make sure when you're putting this design together, you think about, the topology of things. So, and I'm going to cover this in the next slide too, but, how you want to segment your traffic, especially from a security perspective. Think about the traffic flow. Where's traffic coming from? Where's it going? How's it going to get there? Think about size of your environment, the VCNs, et cetera. One often overlooked thing is DNS. Make sure you put some thought into DNS, how you're going to do if you require name resolution and how you're going to do it. You're going to leverage OCI's private DNS services and do like a hybrid DNS. And then connectivity is the other thing to make sure you think about in your design. How are you going to connect to this environment? So the next one, after you've actually thought about and you're putting thought into the design, Oracle's best practice and recommendation is to consider doing what we call a hub and spoke VCN design. So this is a really good way to, when I talked earlier about, how to segment the network, this is a really good way to do that segmentation. So you can create different VCNs as spoke VCNs and put different environments into each one of them. So maybe you've got production in one, non-production in another one. By having them in separate VCNs, you can then apply routing policies with the DRG, where maybe you don't want prod and non-prod to talk to each other from a routing perspective. Maybe you do want them to talk to each other, but you want them to go through some central inspection point, like a network virtual appliance, a firewall, or something like that. Then you can put those firewalls in a separate hub VCN. The DRG allows you to do routing so that you can route those traffic flow and get them inspected with those firewalls. This is also one of our best practices and recommendations because this is a very scalable topology. So the DRG, for example, can support as many or as high as 300 VCNs attached to it. So you could conceivably have a hub VCN and as many as 299 different spoke VCNs, each with their own different routing rules or connectivity requirements. So it's a very scalable topology. Even if you don't require this, like you don't have all these different environments, you don't have maybe I've seen some customers put either their internal or external customers in different VCNs. If you're just starting out small and you just have one environment and it's got one VCN, that's okay. Because the way I look at it, that might just be spoke one of a hub and spoke topology you could do in the future. You could easily add additional spoke VCNs as you grow. You can add that hub later, and you don't have to change anything with that original VCN that you deployed. So you still can participate in this design going forward. Okay, the other thing, which you guys are kudos to everybody on this session right now because you're taking advantage of it, but there is a lot of learning out there that we provide in Oracle. And what I've noticed is a lot of customers are, tend to be very new to Oracle, new to OCI, taking a little bit of time and making sure especially your network team really understands all the networking components. A lot of times they're familiar with maybe some other cloud providers. What is the Oracle version of it? What's different about it? There's a lot of resources out there for you to help educate and learn. So we've got an Oracle Learning website as an example. You can go and do some courses and learn some things. There's a YouTube channel that is out there. We have in the YouTube channel, there is an OCI networking series that we've done to kind of take you through step by step. There's also a blog, A-Team blog, myself, Rafi, Farisath, Shailesh. We all actually author blog on a regular basis on that site. We also post some of those videos up on the YouTube channel. We also have a live labs where you can go and actually test out some things in your own environment. You can do a live lab, for example, on DNS, private DNS and hybrid DNS. You can do a live lab on multi-cloud that we have up there. And then, of course, today, these day one and beyond webinars and workshops. Also, my group, when we engage with customers, we can run them through what we call workshops, which are very educational based and led by us. And it's very interactive. You can ask questions, etc. So make sure and reach out to your Oracle account team as well if you want to see about taking advantage of any of those workshops. And then rounding out the last network design best practices. One other thing that I see on a regular basis is we go into the console and I'm watching the customer and they provision a network resource like a DRG. What very first thing they have to do is give it a name and everybody kind of pauses because nobody knows what to call it. So just make sure you have like a standard naming convention. And this goes for not just networking across your entire tenancy and infrastructure, because it helps to eliminate confusion. If somebody else is going to come in and look at something, they're not going to know what it is. They might be looking at the wrong thing. Also, some things, it can get a little tricky to rename them later. What I always recommend customers do is try to use the acronym for what you're creating. For example, the DRG, maybe put DRG somewhere in the name, security list, maybe SL, something like that, just so that some other person 6 months later knows, okay, I'm looking at the DRG, I'm looking at the route table, whatever that is. Another recommendation, subnet types in OCI cannot be changed, so they can come in different flavors. You can have public versus private. You can have AD specific versus regional. Once you provision those, they can't change later, and it can get difficult to try to move resources if you want to create new ones. So just take a little bit of time, make sure when you're configuring those subnets, which type you need and when you actually create it. And from a security perspective on that one, another recommendation, just, don't or be very restrictive about how many and how often you're creating public subnets. I have seen customers their knee-jerk reaction is to make every subnet public. It only takes some other person making a change in a security list somewhere, and they may actually open up that whole subnet to the internet when you didn't want it to. Talk about designing those VCNs. Think about sizing the CIDRs for those VCNs, not just for what you need today, but put some thought into possibly allowing growth in the future. We do allow customers to add additional CIDRs to the VCNs to grow it. But what I've seen is a customer will go and put a very small CIDR to start with because there's only one workload in there. And then 9 months later, they want to add more. They want to do something else. It's not big enough. They go to take the next, they go to increase the CIDR, and the next available CIDR in their IP allocation tool is taken by someone else. Still works. It still can be done. It's just at that point, it can get a little messy because your CIDRs are not contiguous, and you don't allow yourself to be able to summarize the IP space down the road by using one larger block. Then the last best practice here, when you provision a VCN, you get a default route table and a default security list. The recommendation here is to, instead of using those default ones, create custom ones for every subnet. And then that way you can be very specific about the routes and the security rules that you want to allow on each individual subnet. The example there is you might have a public subnet and a private subnet sharing the same route table. However, you need a default gateway for the public subnet going to the internet gateway, default route for the private subnet going to the NAT gateway. You can't do that on a shared route table. So create create custom ones for each subnet. And then you can be very specific on your rules, your route tables, entries of only what you need for that subnet. Okay. You ready for the next section, Rafi?
Yeah, absolutely, Ben. No, thank you for taking us through that. And before I begin, so thank you for presenting. Just a quick question for you, please. So let's assume I am one of those customers where I've implemented a flat environment and I really do want to go to a hub and spoke model. Does that mean I have to tear down my existing workloads and re-implement, or is there an easy way to pivot to a hub and spoke architecture?
No, that's a good question. We get that a lot. So going back to kind of what I said earlier too about, if you have one subnet, you could potentially one VCN to start with. You could potentially use that as your first spoke, and then, any additional things you deploy, create other spokes for that hub and spoke topology. I do have some customers that, because it can get a little bit tricky to move things around, but it certainly can be done. Most of the times when I work with customers on this, they typically like to take the approach, especially in a production environment, of creating the hub and spoke topology for going forward in new environments and keeping the existing the way it is. And then that you can go at your own pace. Maybe down the road, you can look at the existing environment and kind of figure out a project or how much work effort it's going to be if you wanted to tear that individual VCN into different spoke VCNs. But typically, I see customers doing it just for future going forward.
Perfect. So it's an iterative design, and I could pivot and introduce the hub and spoke model. Thank you, Ben.
Yep.
Next slide. All right. So our next session is going to cover our OCI network security best practices. And to start off with, we have what we call the CIS landing zone as a quick start template. Now, before I start talking about the CIS landing zone and what it offers, let's briefly talk about what CIS is or who CIS is. So CIS is the Center of Internet Security. So they're essentially a community driven of third-party organizations that have created controls and benchmarks to help customers secure their data across many different vendors and environments. So essentially, they're the best practices to secure a configuration of a target system, the target system in our case being OCI. And they're also developed through a unique consensus-based process comprised of many different cybersecurity professionals and subject matter experts across the world. Now, our CIS landing zone is highly automated. It is made using Terraform, and we've taken into consideration the architectural components that are required to build and scale an existing environment while making sure that resiliency, security, and availability are also thought throughout this process. So the primary objectives of the landing zone essentially are to reduce the time to start and deploy, provide an architecturally strong foundation, whether it's security or resiliency or availability, and again, the ability to maintain the flexibility to customize and evolve and iterate upon our existing implementation based on our organization's needs or requirements. So when we start talking about CIS landing zone and the architecture, what are some of the components that are going to come with the CIS landing zone? Well, compartments, they're thought out for us, and compartments are used to organize and isolate our resources within OCI, want to make it easier to manage, but also secure access to them as well. We've thought about the tagging, so that way we can organize a set of resources based on our business needs. We've given the budgeting and alerts a lot of thought where we can use the budgeting to set the soft limits in our OCI spending and let the alerts notify us when we're close or might be exceeding our expected budget. We also have thought about the identity access management portion of this. This is to securely control access to all of our resources within OCI. And of course, network and connectivity, where we do, just like Ben was talking about with the CIS landing zone now, adopt the hub and spoke model. We do create the virtual cloud networks, the subnets, and any other networking component that is going to be required for connectivity and the resources. And essentially, we do leverage a hub and spoke model for this. And of course, security. So on day one, leveraging the CIS landing zone, security is a core component of this. We have given this a lot of thought, and we enable a strong security posture on day one by leveraging the security services within OCI. A good example is Oracle Cloud Guard, for example, or the OCI Vulnerability Scanning Service, or the OCI Bastion service. So architecturally speaking, we've thought about many different components, and this is not a hard set it and forget. We do have templates within the OCI console. We also publish the CIS landing zone in GitHub repository where you can download it as a customer and update it and tweak it to your business use case. So when we talk about network connectivity, again, one of the key components, and we are going to harp on this, is the ability to design a network architecture and be able to segment it in a highly secure fashion while still being able to provide a functional environment for the workloads. So again, we are believers in this hub and spoke model. And so off of day one, as far as the network architecture is concerned for the CIS landing zone, we not only provide a hub and spoke architecture, but we actually provide two distinct hub and spoke architectures, one for your production workloads and the other one for non-production workloads. So again, this is a very powerful tool. This is definitely a security best practice, and this is available within GitHub or within the OCI console for us to be able to take this and take our cloud infrastructure to the next level. So the next topic, as far as network security best practices, are the use of network security groups. So of course, here at OCI, we do recommend we leverage network security groups, or NSGs, as much as possible. Now, before I start going into the benefits of an NSG, let's talk about what cloud native services are available when we compare an NSG to, let's say, the security list. So with that said, security lists, they let us define a set of security rules that applies to all the virtual network interface cards, or what we refer to as VNICs, in an entire subnet. Whereas the network security group, it's going to be able to give us the ability to provide a much more granular filtering and control of traffic flowing to and from an individual or a group of VNICs. So the NSG approach allows customers to implement microsegmentation strategy, whereas a security list applies to the entire subnet. The ability to provide NSGs to use microsegmentation strategies, of course, right, that's going to help us reduce the total attack surface in the event of a network security incident. Now, services that are supported by NSGs, there's quite a few. There's documentation out there, but I just want to go through some of them. Our compute instances, right? Our load balancers, our database systems, mount targets, DNS resolvers, Kubernetes, right? And the list goes on. So those are just to name a few. And again, going back to the original, why do we recommend NSGs over the security lists? Well, that's because the components, they're going to have, again, much more granular security controls, and we have the ability to leverage a microsegmentation strategy. So based on all of this, this is why we here at OCI are always going to refer customers to leverage network security groups as much as possible in lieu of security lists. And our final topic for network security, essentially, we offer several native services. So I'd like to cover the OCI Bastion service. So the OCI Bastion service essentially is it's an alternative method to securely connect to our OCI resources compared to the traditional jump box method or a Bastion host on a public subnet. One beneficial note here is that the OCI Bastion service is a free service, and it is managed by Oracle, right? So we don't have to go in there and manage these servers, make sure that they're patched, they're up to date. The Bastion service also seamlessly integrates with IAM for more control and access restrictions. And these OCI Bastion service sessions, by default and by design, are short-lived sessions. So again, this will give us the ability to have a greater security posture because we don't necessarily have a publicly exposed Bastion service available on the internet 24/7. The next topic would be our OCI Identity and Access Management service, which this is key, right? It's a part of our OCI landing zone, but it lets us essentially control who has access to which cloud resources. So we can essentially control which type of group or a set of users has access to which specific resources in OCI. Network resources, for example, that you provision inside OCI are typically part of the core building blocks in your architecture, and you want to limit this or restrict them to just the network folks, for example. And that way you could prevent unauthorized users from creating or changing resources that could inadvertently lead to either downtime or security holes. Very simple common approach is to create a policy that limits the ability to manage the OCI cloud network to a specific set of network administrators or network engineers. And finally, of course, many customers that we often work with, while they do leverage security lists and network security groups, may have the need to have additional functionality or features or capabilities than your cloud native security services. So here at OCI, we do have the ability to deploy an OCI cloud native firewall, which is a next generation firewall. And in addition to that, we also have a large number of third-party firewalls that have been certified to use their product here in OCI. So if we were to talk about security lists and security groups, they are both stateful layer 4 firewalls. You do have the ability to turn them into stateless if you wish. But let's talk about, if you needed additional items, right? Such, in addition to intrusion detection, URL filtering, and SSL inspection, which is offered by the OCI native firewall, maybe some network address translation, whether it be source NAT or destination NAT. then customers do have the ability to look into, again, quite a variety of third-party marketplace firewalls within our OCI marketplace as well.
Rafi, going back to the network security group versus security list, it's not always an either or for that. How do they work when they're used together?
That's actually a really good question. Probably one of the most common questions we get asked, because I do have customers that I deal with say, hey, Raf, I've only allowed this specific resource on the network security group, but it seems like all other resources are able to reach my resource. And so essentially, when we take a look at the security lists, which are applied to subnets, which include all the VNICs within that given subnet, versus a security group, which is only applied to a specific VNIC, this is going to be the union of the two. So when I say union of the two, specifically the security list and the network security group, and it's going to be the most permissive of the two. So I think it's good to talk about, right? We do explicit allows, whether it's in a security list or a security group, meaning everything else is implied denied. So if I do have an allow in a security list, but then I have a very granular network security group, and that network, so the VNIC is a part of the same subnet where that security list is a part of, then it's going to be the union. So if I'm allowing it in the security list, then my VNIC is going to accept it, even though my NSG does not have that security rule defined. So hopefully that answers that question for us, Ben.
Thanks, Rafi. So let's move on and talk about network connectivity best practices. So for network connectivity, it kind of the big one here is redundancy. This is another one that I think Rafi would agree with me. We see on a regular basis. Customers may think they have redundancy, proper redundancy, but you go in and do a little digging and checking, and it turns out that there is a single point of failure somewhere. So the recommendation here is to do a validation if you already have multiple connections into OCI, and just make sure that they are in fact redundant. So there's some things that you can see or we give you access to in the console. For example, the DRG will tell you whether there's redundancy or not. You can go even further into it and look at your connections, and we'll tell you, for example, which physical or which logical device in Oracle that it connects to. So you could see that maybe your first FastConnect goes on router 1. You go into the second one, it goes to router 2. So that's a really good way of validating that, okay, I've got, diverse paths here. It's at least in the Oracle part, it's terminating on separate routers. Also go into those DRG route tables and just make sure, like on FastConnect on the BGP, that you see if they're redundant to each other, you should see the routes over both of them. And in the route table, we'll tell you that one of them is green and active and the other one is red in conflict. Just go and make sure that you see that and it's the way that you want it to be. For VPN tunnels, we give you on an individual VPN connection, we actually give you 2 tunnels that you can use in OCI. Those will automatically go into diverse logical devices on the Oracle side. But on the other side, it's important to look on-prem as well. If you terminate those both on the same CPE on-prem, then there's your single point of failure there. Maybe think about if you have a second CPE, maybe you could do 2 IPsec connections, one going to both, so that you actually can have no single point of failure across the entire tunnel. The other recommendation here is to make sure you test it. I would recommend doing a failover test prior to you putting anything into production, and then maybe on a regular basis, 6 months, 9 months, whatever makes sense for your organization, get an outage window and just do a quick test and make sure it behaves the same way. Because after 6, 9 months, sometimes people go in and make changes to things. And if it doesn't take down your primary path, you may never know that the backup path was affected until you actually test it. So make sure you perform those tests on a regular basis. When it comes to FastConnect, another best practice or recommendation from us is to consider using a partner for FastConnect. FastConnect comes in a few different models. There's a direct connection. There's a third party where you, as the customer, bring in some third party carrier maybe for the connection. But if you can find a partner that you can use, the partners are already physically onboarded into our data centers and our POPs with the appropriate level of bandwidth and redundancy already built into it. So if you use one of these partners, you get a certain level of redundancy already. That will depend on the type of FastConnect and which partner you use, but the provisioning using a partner-based FastConnect is very, very easy and simple. Typically, you just go into the Oracle console, you provision the FastConnect, you take the OSIT out of there, and you go to the partners console and portal and finish it. Typically done within minutes, maybe hours at the most, depending on the partner. And it's relatively inexpensive because it's essentially a shared infrastructure. So the physical connections are already made. And so you're just getting essentially a virtual connection over on top of that. So it can be a relatively low cost FastConnect. Also, we've got a very large ecosystem of FastConnect partners. The latest numbers I've seen is over 100 unique partners all over the world and over 800 individual partner connections in all of our regions. So it's should be a pretty common thing that you could find one of those partners. I would recommend, start by looking at the list and see if there's any partners that you already do business with. Maybe it's a carrier that you already use, or maybe it's another cloud connectivity provider. But typically I find that customers, if they already have a relationship with that partner, it's much easier because then, you don't have to go through your corporate procurement or get your legal to look at their T's and C's on their contracts and stuff like that. It can be very quick and easy because if you already use them, you've already got a contract. It makes it simple that way. Okay, and the last couple here, best practices on network connectivity. Make sure you understand when you need a VPN tunnel versus when you need a FastConnect. This is another one that I see a lot of. A lot of times we see customers, kind of their knee-jerk reaction is to build a VPN tunnel first because VPN has been around for decades now. They probably already have firewalls or CPE devices where they do these types of VPN tunnels today. It's very simple and it's very easy. They trust the protocols, IPsec. It's been around. However, just understand there's you are going over the internet. You could have poor performance, latency, jitter, bandwidth issues that might move you towards requiring a FastConnect. So make sure you understand that ahead of time because you don't want to go deploy your resources and workloads and realize that they're not performing well, and it's because now you need a FastConnect and it's an urgent thing. And then the last one here, very similar to the default route table and security lists that I talked about earlier. When you provision a DRG, you're also going to get these default DRG route tables and import route distributions. And if you look in the console, they're going to be named auto-generated route table for this, auto-generated import route distribution for this. Those are default. They are made for the most basic types of connections. If you have one region, one VCN, one on-prem, those are going to work just fine for you. However, once you want to start doing something a little bit more advanced, then you're gonna need to change those route tables and import route distributions. The recommendation here: leave the auto-generated ones alone and go create your own route tables, DRG route tables for your VCNs, your FastConnects, and then import route distributions very specific to those that are only allowing the actual traffic and routes that you want it to. what you'll find is if you take those auto-generated ones and you just use those and change them to meet your needs, can cause confusion down the road, especially with OCI support. They might see that you're using auto-generated and start, thinking it's the default ones when you've actually changed it. You can go down rabbit holes and down some paths of troubleshooting that you could save some time if you just create some custom ones, and you can be very specific about the routes that you actually want to import and allow. Okay.
Excellent, Ben. So just a quick question here, please. So let's say I've provisioned multiple FastConnect circuits. They're all behaving. Everything is working fine. But it's not in the order I want. So for example, my FastConnect circuit 2 seems to be the primary circuit. My FastConnect circuit 1 seems to be the secondary circuit. Is this something I should just accept and live with, or is there something I could do to follow my preference?
No, like you mentioned, like if you provision a couple fast connects, they're gonna work, they're gonna share routes, and they're gonna fail each other over. But if you don't do anything else, you're just kind of leaving it up to the default parameters of essentially of BGP of which one it wants to choose as the primary. That may not be what you want. You can go in using BGP attributes. You can modify those on your CPE side to be very predictive about which one you want. So we also have a PDF, a redundancy guide PDF that kind of lines this out pretty well. But essentially what you can do is on the backup path, you can AS path prepend the routes going to OCI. We will see those on the backup and not prefer the backup. In the reverse direction, when you receive routes on the primary on the CPE, you can do something like BGP local pref to make the primary more preferred, and then you've got 100% of your traffic going over both direction on the primary. If it were to go down, the only other option is the secondary at that point. So it's very predictive at that point.
Perfect.
Thanks.
Okay. Thank you. So I can make this fully deterministic by using BGP attributes.
Yep.
Thank you, Ben. Perfect. And so I think this is our last section for our OCI network and security best practices, specifically covering our network observability and management best practices. So to start off with, so let's see here. To start off with,
Sorry.
Yeah, no, thank you, Ben. Perfect. Here are some of the tools that I'd like to discuss. So here within the OCI, we have what we call our network command center tools. And these are really great tools. And if the folks in the audience have not had a chance to go in and experiment with this, I highly encourage you guys to do so. So there are a few tools that I do want to talk about. I'm going to start off with the network visualizer, and then we'll talk about the network path analyzer, our virtual test access point, and some of our inter-region latency numbers. So to kick it off, within the OCI console, we have this really neat feature. It's called the network visualizer. And essentially what this does, it provides a diagram of our topology on a regional basis that are made up of the components that are used within that regions. So let's take a quick recap, right? So within Oracle Cloud, we have constructs. We have the virtual cloud network. Within there, we have subnets, gateways, and other resources. And these entities, right, they are related and they're connected to each other through routing. That's often complex. So the resources, it would be nice, right, to be able to view these in one common area. And that's exactly what the network visualizer does. Now, within the network visualizer, we're going to have a few levels of visual patterns that we can see. So one is a very high level layout of the routing topology at the regional level. And here you're going to see everything. You're going to see your VCNs, you're going to see your DRGs, you're going to see your FastConnect circuits, your IPsec tunnels, your remote peering connections. If you have a hub and spoke architecture, local peering gateways, all of it's going to be depicted here. And we're going to see the relationship between all of these constructs to and from each other as well. Now, what's really neat is we can actually start drilling down to this even further. So there's the VCN, right, the virtual cloud network topology level. So if we were to drill down into a VCN, we could further see what subnets are included, what types of gateways are included, what VLANs are included. And then we could take it a step further and drill down within the subnet as well. And within the subnet topology, we're able to see information about instances, load balancers, and other components like Oracle Kubernetes engine or maybe file storage service, right? But the key thing here is that you have on day one, as you're building your environment, a real-time view of what your architecture looks like on a per regional basis. So very handy tool. We have a lot of customers using this. And again, if you haven't had a chance to experiment or take a look at this, not just this tool, but all these other tools that I'm about to talk about, definitely worth going into. So the next tool under our Network Command Center would be what we call our Network Path Analyzer, or our NPA. So this essentially provides a very intuitive capability that we could use to identify the virtual network configuration issues that may impact connectivity, right? Because the NPA, what it does is it collects and analyzes the network configurations to determine how a path between a source and a destination should work. And it's going to tell us whether this is functioning or if it happens to fail. One key thing to note here is we're not actually sending traffic. Instead, we're validating the configuration to see if reachability can be achieved or not. So we have a lot of customers using our NPA for a variety of things. Troubleshooting, routing security misconfigurations that are causing connectivity issues. So if there was a route missing in our OCI route table, we would highlight it. If it was being blocked by a security list, we would highlight that in the Network Path Analyzer as well. Oftentimes, another good thing, time to use this is oftentimes we do configurations and it's working, but then maybe it's not working through the path we intended to. So after we do configurations, we can actually go and validate the logical network path to see if it actually matched our intent, right? And the third thing is we could see, before even deploying or before even handing off to our app dev teams, for example, we could validate ourselves if the virtual network connectivity is going to work or if it's going to fail, right? The last thing we want to do is say, hey, everything is built from an infrastructure perspective, start handing it over to database or app dev teams, and then, right, things are falling apart. So again, I would highly encourage everybody, if you haven't had a chance to work with the Network Path Analyzer, to go in there and start taking a look at it. Some of the paths or the data flows that we support, of course, OCI to OCI, but we also support network path analysis from OCI to on-prem and vice versa, and of course, OCI to the internet and vice versa. Perfect. So just a couple more items here, and then we'll move on to the next section. So Virtual Test Access Point, or VTAP. Essentially, in Oracle, it provides us a way to mirror traffic from a designated source to a selected target. And this is going to be very beneficial to facilitate troubleshooting, security analysis, or data monitoring. So we do have customers that are either actively using it to troubleshoot, or they may have security and compliance requirements where they need to mirror the traffic and keep it for 90 days, 60 days, whatever that number happens to be. So the VTAP service is ideal for these types of scenarios. And the last thing here is the what we call our inter-region latency map. Now, our inter-region latency map provides two data sets. One, the real-time current inter-region latency round-trip time between two OCI regions, or a historical round-trip time, the RTT, in milliseconds for the last 30 days. Now, this is good information to have when we start planning out whether we're going active regions within OCI or we're planning our DR regions within OCI on a per continental basis. We could take a look at this inter-region latency map, and based on the latency between OCI's regions through the OCI backbone, right, customers can make a decision, an educated decision on where or which region to start leveraging as they start scaling their cloud infrastructure out. So again, for anybody here who has not had a chance to go through these, I would highly encourage you guys to go and take a look at our Network Command Center. And So of course, when it comes to observability, this is something that's often missed, and it's unfortunate, right? Because a lot of the things that Ben and I have talked about so far are items that you would normally think are thought out, but it's, again, we tend to miss it, or we just haven't thought about it. We don't have too much exposure to it. So uh, notifications and alerts, right? These are very, very big. So within OCI, we have what we call the OCI audit service. And the OCI audit service, it's automatically collecting all the calls to our public API, and then it's logged into our audit log. So essentially, this includes all API calls made by the console, or the CLI, or our SDKs and other OCI services. So that audit log is very rich in information. It's collecting a lot of things. So what customers can use is they can use OCI events and notifications to proactively be alerted, let's say, when a change is made to a critical or key network component. So what we're saying here is, let's say if we had a group, we hadn't leveraged IAM properly, and we had an app dev group that was in there, they may have made a change to a security list, network security group, or a network firewall, or a route table, or VCN, subnet, DRG, any one of these, right, key critical network components. We could actually get notified on these events. So essentially, what we want to do is identify the key and critical network resources that we want to be proactively notified when changes are made, and be able to alert upon that. And so using the audit service, the audit log is capturing this. However, the OCI monitoring service, right, is also another way where we can use metrics to monitor resources and alarms to notify us when these metrics meet the specific alarms. So we can also create an alarm on any of the metrics that are being captured by the OCI monitoring service and make decisions based on those. So ideally, we want, by combining the metrics and the alarms with the OCI notification service, we're going to be able to get notified when, not only when, changes are made, what we're talking about the audit service, but if any threshold on a specific metric is triggered. Now, what are some of these thresholds we're talking about? Well, maybe the state of a FastConnect or a site-to-site VPN goes from up to down, right? From a 1 to a 0. If we're using the OCI monitoring service and we are making a decision based on that metric and creating an alarm, we will be proactively notified if our site-to-site VPN or FastConnect circuit happens to go from up to down. Or maybe it's not a hard down. Maybe the traffic, right? Let's say we're always expecting a few gigs of traffic across our FastConnect circuit, but then all of a sudden it just, doesn't go to 0, but it's very, very minimal traffic, right? So we could set up a new alarm based on this threshold if, let's say, the traffic goes above or beyond or below a certain threshold. Similarly to the FastConnect and site-to-site VPN service going up and down, right? Another good metric that we could always monitor would be our BGP session, the state, whether it's up or down, right? So being able to leverage the OCI monitoring service or the OCI audit service and coupling them with the OCI notification service, we're going to have a lot more visibility into OCI and what's happening, and be proactively notified before the event spirals out of control. And so otherwise, I think this is pretty much going to conclude our session, or the section for this topic. So again, if you haven't had a chance to look at our observability management tools, or if you really haven't set up your OCI monitoring or audit service and notification service, now's the time to do so, because the last thing you want to do is get notified of an outage when things have gone severely south, when you could have actually been notified and probably made those decisions to rectify the situation a lot earlier and sooner on.
So Rafi, let's say a customer has created a notification for when his FastConnect goes down. Are there any scenarios where that connection would be down, but OCI never sends an alert?
Yeah, that's a really good question, Ben. Yeah, absolutely. So when we start talking about, of course, right, this is an OCI Day One and Beyond series. However, as a general best practice, there could be a time, right, your FastConnect circuit is up and you're going through a third-party provider, maybe something in transit happens to be down, your OCI circuit is still going to be up and you would not receive that notification. So there could be a time, let's say OCI FastConnect circuit's up, but your customer premise equipment, that circuit going to your upstream provider might be down. Again, we're not going to receive the notification on the OCI FastConnect. So when we talk about monitoring, it's not just monitoring OCI. Let's try to monitor the path end to end. We'll monitor our CPEs. Let's monitor our circuits from on-prem upstream. If there's any hops in between, say, the customer premise equipment and OCI from their provider's perspective that the customer can monitor, all of these should be taken into consideration because we can have any one of these moving parts fail except for the OCI, and that's going to be up, and we're not going to be aware that paths are down. So when it comes to monitoring, yes, there could be a situation OCI is up, some other downstream environments down, which is outside of OCI's control, and it just would not trigger that alarm. So it's always best to monitor our network paths end to end.
Thanks, Rafi. Well, that's what we have for today.
I'm just looking at the unanswered questions. There's one question on, is there a way to make a health check? Don't know what that is in reference with.
So if we're talking about health checks on the FastConnect circuit, essentially it's going to boil down to our monitoring service coupled with the alarms to leverage the metrics and essentially the state of the FastConnect circuit, right? Whether it's up or down. Usually that's identified as a 0 or a 1. So 1 means it's on or up, 0 means it's off or down. And based on that, that's essentially the health check. Just want to see our metrics to identify and avoid outages. So it is difficult, right, to identify and avoid an outage. Usually this is where resiliency and redundancy will come into play. And I think Ben had probably mentioned earlier, right, to be able to exercise your resiliency patterns and not necessarily wait for a certain event to be triggered, like an outage. So it's always good to exercise those off rotation. I've seen customers do it annually, some do it biannually. But anything you'd like to add there, Ben?
No, but I think maybe if Marco's question is how to see the metrics, you certainly can, like on a FastConnect, you can go to the FastConnect itself. And typically the metrics that we publish will be right there on that page. One of them I know on the top one, I think, is the status, which is up or down. I think there's some of them we might show the BGP status, whether it's up and down, bytes in, bytes out, bits in, bytes out, those types of things. You can see that in the actual console.
Thank you, Ben.
Awesome. And Rafi and Ben, since we have a couple more minutes, I had a quick question for you that when the notifications are sent, does it wait for a confirmation that it's received? And if someone doesn't confirm, then how does it send it again? How does that work?
As far as the sorry, Ben, please go ahead.
My understanding that there's one notification is sent. It's not looking for any confirmation.
Mm-hmm.
Most customers I work with, they send the notifications to a group email so that more than one person were to get it, in case that one person's on vacation or something. That's typically what their recommendation is. But I don't think it's not looking for any acknowledgement of it. If the FastConnect went down, it just detects that it went down, and then the notifications, how it's configured, it sends it out to the group email that will receive it.
Awesome. Thank you so much. Really appreciate all the time both of you put in here and making this session so interesting. So Ben and Rafi, thanks for that. And thank you, Salesh and Firasuddin, for answering those questions. You guys were pretty fast there answering all these questions. Moving on, monitoring of your cloud resources is one of the pillars in maintaining strong security posture of your tenancy. So join us on Monday, August 19th to learn about various OCI security services like OS Management Hub, CloudGuard, Threat Intelligence Service, and much more on that. I would recommend that you bookmark the Devon and Beyond page and check frequently for new sessions on trending topics. We did make a note of repeating this session or adding more on networking best practices, so we'll keep that in mind. So thanks again, all of you, for joining us. See you all next time. Have a great day, everyone.